Yeah, namaste. After finishing the topic sets, set theory, we have the next topic, relations. In the title itself, you can see the relation. And this word relation is very frequently used in our day-to-day life. Now, what exactly the relation is, we will be understanding now through the Cartesian product. What is a Cartesian product? You can see in the previous session of set theory, you have got the Cartesian product. If you have two sets A and B, and if A and B are two non-empty sets, and if you write the ordered pair from set A to set B, then it is said to be the Cartesian product. That is, every element of set A is associated with every element of set B, then it is said to be the Cartesian product, and it is denoted by A cross B. Everyone knows that. We have seen that in the previous session. This is A cross B, and here it is denoted by A comma B, where A small a belongs to capital A and small b belongs to capital B. This is the definition of the Cartesian product. Then how do we define the relation from the Cartesian product? If you take any subset, subset is the set which is a part of a given universal set. So any subset which is contained by A cross B, that is the Cartesian product, is nothing but the relation. So let us understand this through an example. Let me move on to the board. This is, let me take a set which is containing some elements here. That is, let us have a Venn diagram for the elements of the set A and another oval shape for set B. Now I have A, B, C as three elements in set A, and 1, 2, 3, 4, let me say, as the elements of set B. Then if I associate set A to set B, which is every element of set A is associated with every element of set B, we denote this with A cross B, and it is known as the Cartesian product. And it is, you can understand, it is A to 1, it is A to 2, A to 3, A to 4. That is, A can be associated in 4 different ways: A1, A2, A2, A3, A4, and if you associate similarly B to the set B, small element, the element B to set B, then it is B1, B2, B3, B4. This we have already learnt in the previous session. Similarly, C1, C2, C3, C4. And these many elements will be there in the Cartesian product. That is A cross B. How many elements are contained in A cross B? you can check the n of A cross B is nothing but there are 3 elements in set A and 4 elements in set B. 4 into 3, that is 12 elements will be there. Just understand, my dear boys and girls, you can have 12 elements in the Cartesian product. So if you take any part of it, that is, we call it as the subset. That means, let me write that, let me name a relation. Let me name a relation like this. Let me define R. That is a relation A, R, B as, I'll be taking some elements from this one. A1 I have taken and B4 I have taken and C3 I have taken. Just observe that this A1 is very much present in the Cartesian product, B4 is also present and C3 is also present. So such elements, they are all a part of A cross B and we call it as the subset. The subset of A cross B is nothing but a relation. My dear boys and girls, understand that. So, what is the broad understanding about the relation? Relation is subset of A cross B. So, A cross B contains all types of relations. A cross B contains all types of relations and if you take any subset of A cross B, that becomes the relation. Now, after understanding the relation, what exactly again the relation? It is the subset of A cross B. Now, you will be understanding different types of relations. Obviously, satisfying the definition, you will have different types of relation. Let us now understand the definition in the printed format so that whenever you go through the definition in any textbook or in any book, it will be easy for you to understand it. So, let me move to the printed format of it. That is, just check it out, my dear boys and girls. Let A and B be two non-empty sets. Then every subset of A cross B defines a relation from A to B, and every relation from A to B is a subset of A cross B. Every relation from A to B is a subset of A cross B. So, that's what I explained. Now, it is denoted like this. You must understand the notations. It is R is subset of A cross B and AB belongs to capital R. Then we say that A is related to B by the relation R and we write it as ARB. What is the meaning of ARB? A related to B. If AB belongs to capital R, we write it as ARB, A related to B. So, let us take the example. A is equal to 1, 2, 3, 5, 8, 9 and B is equal to 1, 3. We set a relation from A to B as ARB if and only if A is less than or equal to B. We define the relation. What is the relation here? A must be less than B or equal to B. Then how many such elements you find here? 1, 1 is one relation and 3 of course is not there. So, how many such we get here? Then R is equal to 1, 1. Why should we take 1, 1 there? Because A is less than or equal to B. And similarly, A is less than B. That is, if you take 1, 1 is obviously less than 3. So, 1, 3 will become an ordered pair here. Similarly, if you take 2, 2, 1 is not suitable because A must be less than B. And if you take 2, 3, that is suitable very much. So, 2, 3. So satisfying that definition, A less than or equal to B, you have three elements present in the relation 1, 1, 1, 3, 2, 3, which is subset of A cross B. So whatever the relation you take, it will become the subset of the Cartesian product. So let's move on to the next part of it. That is, if you take any total number of relations, my dear boys and girls, if you take total number of relations, how many total number of relations are possible if we take two sets? Total number of relations, just check it out. Let A and B be two non-empty finite sets consisting of M and N elements, respectively. Then A cross B consists of M into N ordered pairs. That's what I have explained in the example. In the set A, I have taken 3 elements. In set B, I have taken 4 elements. Total number of elements in the Cartesian product will be 3 into 4, 12. That's what he's saying. M into N ordered pairs you'll be getting. So total number of subsets of A cross B is 2 power Mn. 2 power Mn. In set theory, we have seen the power set, the number of elements of the power set is 2 power n. That is, if you have a set 1, 2, 3, how many subsets will be there that are formed from 1 to 3? You know, we have seen that in sets itself is 1 is one subset, 2 is another subset, 3 is another subset, 1, 2, one subset, 1, 3, one subset, 2, 3, another subset, 1, 2, 3 itself is another subset, and 5 is a null set is another subset. There will be 2 cube subsets will be there. So the power set consists of 2 power the number of elements in the given set. Similarly, here also, wherever Mn elements are there, Mn ordered pairs are there, the number of relations that can be formed will be 2 power Mn, which is nothing but the number of subsets, because every subset becomes a relation. So 2 power Mn relations will be there. So among these 2 power Mn relations, the void relation phi, that is like null set in set theory, we call it as void relation denoted by phi, and the universal relation A cross B are trivial relations from A to B, are said to be trivial relations from A to B. And the next one is domain and range of a relation. In the domain and range, broadly understanding, my dear boys and girls, domain is simply the input and the range is simply the output. So whatever the input is given in the mathematical terminology, it is said to be the domain. Whatever the output you get in the mathematical terminology, it is said to be the range. So domain and range of a relation is simply, if you or defined a relation R from set A to set B, then set A is called the domain of the relation and set B is said to be the range of the relation. That's it. We'll be understanding through the example. Then the set of all first components or coordinates of the ordered pairs belonging to R is called the domain of R, while the set of all second components or coordinates of the ordered pairs in R is called the range of R. That's what I said. Input, domain, and output, the range. If you want to write the domain R is equal to A is such that AB belongs to capital R and range R is equal to B such that AB belongs to capital R. So first component is nothing but the domain and the second component is nothing but the range. Simple understanding about the domain and range, not only in relations but in functions also. This domain and range plays a major role. You must have more and more clarity about the concept of domain and range, because while drawing the graphs of any functions further, domain and range are the primary needs to draw the graph. So you must have very good idea about the domain and range. Anyway, we'll be discussing in more deeper in functions about the domain and range. So it is evident from the definition that the domain of a relation from A to B is a subset of A and its range is the subset of B, obviously. A relation on a set, let A be a non-void set, then a relation from A to itself, that is a subset of A cross A, is called a relation from the relation on set A. Anyway, whatever it is, the Cartesian product is taken from the Cartesian product itself. The relation is taken as the subset. Let's move to the next part of it.